morning. I just want to take a few minutes with you to go over the net force simulation, the PhET net force simulation from Thursday. So a couple things that you should have had to get your full points. When you set up the small blue and red guy, it doesn't matter in what position you have them situated on the rope. The net force should have still equated to 0. And I can set that up for you just to show you that nothing should happen. The speed should remain at 0, and there should have been no movement. So the answer for what happened to the speed was you could have put nothing, the speed stayed at 0, and you were supposed to have 4 screenshots just of the figures placed at different positions. On slide 5, this was supposed to show you an example of an unbalanced force, and of course we know that means that the net force is not equal to 0. So in this case, it was 50 newtons to the right, that there should have been movement. I want you to think about, though, what kind of motion would we see? Like, how would we be able to describe that speed? And if I were to set that up for you, we would see that the speed is increasing, meaning we would see acceleration. So anytime you see unbalanced forces, think of a change in motion, whether it's from at rest to moving. Obviously something has to accelerate, or maybe if something is moving at a constant speed and then slows down or speeds up. An unbalanced force is always a change of motion. Okay, what happened to the forces after removing one of the red players? Forces should have been balanced. You're removing 50 newtons, right? And the forces should be balanced, 50 and 50 on each side. What happened to the speed? The speed remained constant. It was originally moving in the right direction because there was an unbalanced force in that direction. You take one of the red figures 50 newtons away, and the speed should have remained the same. That red dial should have not moved. Still motion, but a constant speed. Forces are balanced. Okay. For this one, kind of a similar situation. You're adding a small blue player. Forces will become balanced. Speed would remain constant. Red should still be moving in the red figure direction. Okay, if you start the game unbalanced towards red and press go, how can you get blue to win? By adding people. So obviously, you can add people so that the forces will move in the opposite direction. So if it's balanced and it's going in the red direction, by adding more people, you can actually change the motion of that to go to the opposite way. Okay. Same thing with this slide. If you start the game unbalanced towards red, how can you get blue to win? By adding people. Oops, that's what I did already. I skipped a slide. Okay, so how can you get blue to win? By removing people. So you can remove both red figures, and then originally it will be going in the red direction. Then you're making it unbalanced towards blue since you took both red figures away, and it should move in the blue direction. Okay, last slide. 6 questions worth 1 point apiece. What does it mean when forces are balanced? Explain in your own words. It means that you can say that net forces are 0. You have the same amount of force on each side. Depending on the situation, you could have no motion, right? If you have an equal amount to start, one small guy going 50, one small guy going 50, there will be no movement. Or it could be moving at a constant speed, where originally you had an unbalanced force, right, to get it moving, accelerating. If you take that away, you can have a constant speed, an unbalanced force. So that also answers number 2. Give an example of a balanced force in real life. Do not use tug of war. First thing that comes to mind, something that's similar to tug of war, is arm wrestling. So if you have 2 people of equal strength and no one's winning at the arm wrestling contest, that you could use that as an example of a constant force. Some people mentioned about in a car when you put on cruise control. I don't know if you are familiar with that option, but there's a button you can press where your speed stays the same. So another example of a balanced force. Remember, there are two situations, constant speed, all objects at rest. Give an example of an unbalanced force. That could be, remember, an unbalanced force is a change of velocity. What is velocity? Speed and, everybody forgets the second part, direction. So if you have an increase in speed, a decrease in speed, or even just a change of direction. Technically, that is an example of a balanced force. So you could be moving at the same speed, but if you're going in a circle, you're constantly changing your direction. So technically, that would relate to acceleration. That would be an unbalanced force. Moving in the same speed, going in a circle because you are changing direction. Number 5, balanced forces cause a change in motion. That one was false. Unbalanced forces cause a change in motion. That one was true. How did you know? You could describe the simulation, how if you have an unequal amount of people, they cause a change in motion. You could have described how when you press go, you can see that speed dial. The speed is increasing right now. Increasing, right? Okay. And if I were to have balanced forces, some people were getting a little bit confused when they were doing this, right? So obviously my speed's increasing. Okay, right now, it's still moving. The speed is staying the same. Some of you put that the speed is 0. The speed is not 0. So the speed would be 0 if the dial was here. The speed is staying the same. There's still motion, right? But there's no acceleration. So some of you got a little bit confused on how to interpret the speed dial and what it's doing. Okay. Like I said, we're going to have a quiz on Friday, a net force quiz. There is a post already to kind of give you a little bit more information on what to expect. 5 questions, 2 points apiece, net force. Know what is an unbalanced and balanced force. Okay, any questions, please reach out to me.